Now the topic of this presentation is different shapes of quadrilaterals. Different shapes and their properties. Now all quadrilaterals have this property that all angles of the quadrilateral add up to 360 degrees. So when we describe a square or any of these shapes, we don't have to say that all angles add up to 360 degrees, because this property doesn't distinguish, let's say, a square from other shapes, because all the shapes here have this property. So let's move it away. What is a square? A square is a shape, it's a quadrilateral, maybe let's make it a bit bigger, that has 4 angles equal and 4 sides equal. Now you can also say that it has 4 lines of symmetry. Here are the lines of symmetry. And the order of rotational symmetry the topic which I will explore later on, rotational symmetry. So once again, the order of rotational symmetry of a square is 4. Now let's move on to the next shape, which is a rectangle. A rectangle has all 4 angles equal, and this one property determines a quadrilateral to be a rectangle. Now, how many lines of symmetry does a rectangle have? If you say 2, you are correct. It has 2 lines of symmetry. Now, what is the order of rotational symmetry? It is also 2. Now let's move on to another shape of quadrilaterals. Here on the list it is a parallelogram. And a parallelogram has 2 pairs of parallel sides. So in this case, AD and BC are parallel to each other, and the other pair is AB and CD are also parallel to each other. It doesn't have any line of symmetry, and the order of rotational symmetry is 2. Now I will skip a rhombus and we'll move on to a trapezium. So a trapezium has 1 pair of parallel sides. It doesn't have any lines of symmetry in general, because there are special trapezia that might have a line of symmetry, and the order of rotational symmetry for a trapezium is 0. So now special trapezium is an isosceles trapezium, And this trapezia, this shape, has one line of symmetry. So, what properties determine this shape to be an isosceles trapezium? So first of all, because it is a trapezium, so it must have two sides parallel to each other, and the other property that it must have is that two other sides are equal and they are not parallel. And here we have to add that they are not parallel because look here, for example, just erase this, and this shape also have two sides parallel to each other and the other two sides are equal to each other, but this is not an isosceles trapezium. So here when we say, or we describe an isosceles trapezium, we'd better add that the other pair of sides are equal to each other and they are not parallel.